Let's imagine if there are no friction, meaning these two walls are smooth surface. What will happen? The cylinder is continuously rotating. It won't be stopped. So, in this case, the wall is providing frictional force against its rotation. Okay, the wall is providing frictional force against its rotation. So that because of the opposing force, the rotation is stopped after few revolutions. So we need to find the number of revolutions. Our question is, we need to find the number of revolutions before it comes to rest. Here the concept is, the cylinder is doing work against the frictional force. So we already studied in previous chapter what is work energy theorem. Work energy theorem is work done is equal to change in kinetic energy. You have to memorize that in rotational motion, kinetic energy is meaning it is the sum of rotational kinetic energy and translational kinetic energy. Here there is no translational motion because this cylinder is completely rotating in this corner. There is no translatory motion. So you can say that the system is in translational equilibrium. Okay, what is translational equilibrium? It's meaning the net force acting on the system is zero. We can say that it is in translational equilibrium. Meaning the upward force is equal to downward force, and the force acting on the left side is equal to the force acting on the right side. See the figure. Here this point is touching the wall, and also here this point is touching the wall. So here the frictional force direction is in upward direction, F1. Okay, and the normal reaction is N1 here. And the weight of the cylinder is always acting downward is equal to mg. And here also touching point, the cylinder is rotating in this direction. The frictional force is always opposing the motion. So the direction of frictional force is towards left. This is F2. And here also normal reaction is N2. Okay. I already told you the system is in translational equilibrium. That means the net force acting on the system is zero. So we can write F2 is in this direction and N1 is in opposite direction. So we can write F2 is equal to N1. Okay. Then what is the equation of F2? F2 is equal to the equation of frictional force. F is equal to mu into normal reaction. The question says in both wall same amount of mu. So F2 is equal to mu into N2. Okay. And F1 is upward, N2 is upward, mg is downward. So we can write F1 plus N2 is equal to mg. This is equation number 1. Okay. And what is the equation of F1? F1 is equal to, in the same way we can write F1 is equal to mu into N1. Okay. Then what is the equation of N1? N1 is equal to F2 and F2 is equal to mu N2. So F1 we can write mu square because mu into mu. Instead of N1 we can write F2 and F2 is equal to mu N2. So we can write F1 is equal to mu square N2. Okay. And F2 is equal to mu N2. F1 is equal to mu square N2. Okay, this is equation number 2. Okay, and this value F1 we have to put in equation number 1. Then what will happen? Mu square N2 is N2 plus N2 is equal to mg. Okay, here N2 is common. So N2 into 1 plus mu square is equal to mg, and N2 is equal to mg divided by 1 plus mu square. So finally we get m2 is equal to mg by 1 plus mu square. Then f2 is equal to mu n2. Same way f1 is equal to mu square n2. So f1 is equal to mu square n2. What is n2? mg by 1 plus mu square. So mg divided by 1 plus mu square. And f2 is equal to mu n2. Mu into what is n2? mg by 1 plus mu square. mg divided by 1 plus mu square. So we find the both frictional force. Then we have to apply our concept. What is the concept? Actually, the cylinder is doing work against the frictional force. Next, we are going to apply our concept. The concept is the cylinder is doing work against the frictional force. So, we are going to apply work energy theorem. Work done is equal to change in kinetic energy. Here, the equation of work is equal to torque into angular displacement. Okay, because here purely rotating motion, there are no translatory motion. So instead of force we can write torque, and instead of displacement we are using angular displacement. Okay, then equation of torque. Torque is equal to force into perpendicular distance. Here forces are F1 and F2. That is F1 plus F2 into perpendicular distance is radius. Okay, then angular displacement theta is equal to 2 pi into, for a single rotation the angle is covered 2 pi. Then for n rotation, we are considering n is the number of revolutions before it comes to rest. So the angular displacement is equal to 2 pi into n. Okay, then work is equal to F1 plus F2 into r, and theta is equal to 2 pi, which is equal to kinetic energy. The equation of kinetic energy here, kinetic energy K is equal to half I omega square. Okay, the equation of kinetic energy is equal to half I omega square. So we are going to equate W is equal to half I omega square. W is equal to half I omega square. W is F1 plus F2 into R into 2 pi n is equal to half into I. I is the moment of inertia. For a solid cylinder, I is equal to mr square by 2. Mr square divided by 2 into omega square. Okay. Here R and R cancelled. And F1 plus F2. See F1 and F2. Here mu mg by 1 plus mu square is common. So we can take it out. Mu mg divided by 1 plus mu square into 1 plus mu. 1 plus mu into 2 pi n is equal to m divided by 2 into 2, 4. And r is remaining here. mr divided by 4 omega square. Okay. And here mass and mass are cancelled. Okay. Mu g divided by 1 plus mu square into 1 plus mu into 2 pi n is equal to r omega square divided by 4. We have to find n, then n is equal to r omega square by 4 into 2 pi. 4 into 2 pi here 8 pi. R omega square divided by 8 pi and 1 plus mu square here into 1 plus mu square, and mg, mu g and 1 plus mu here. Mu g into 1 plus mu. So this is the final equation. Is the number of revolutions before the solid cylinder comes to rest. Today's section is over. If you understood this video, please like and share with your friends. And for more videos, please subscribe our channel and press the bell icon for the notification. And this is Dilshad signing off from BTech Mama. Bye.